Good day, everyone. In case you're hearing my voice for the first time, my name is Will.I.am plus S. In our previous video, or in my previous video, we were discussing quantities and units, though I got interrupted by something. So we'll continue from quantities and unit. So I've explained what quantity is all about and the unit. So we have gotten the unit of the fundamental quantities to be, let's say, quantity, unit, and the symbol. So the first quantity I gave that day was mass, and I said the unit of mass, the SI unit of mass, was kilogram, which is kg. Then we have distance. The unit of distance is meter. And I have time. We have time. The SI unit for time is second. I have current. The unit of current is ampere. That is the SI unit. We have amount of substance. The unit of amount of substance is mole. And have intensity. The unit of luminous intensity is candela. So these are the 7 fundamental quantities. Is there another one? 1, 2, 3, 4, 5, 6, 71. I think we have temperature. So temperature is measured in Kelvin, and the unit of temperature is, the symbol is K. Remember what I gave to you here, what I'm giving to you here is just the SI unit of such quantities. So the next thing we look at, the derived unit. So these are the fundamental units. So the fundamental units, the major fundamental unit we have here now is kilogram for mass, meter for distance, and second for time. So these are the major fundamental SI unit. So when you combine this SI unit now, the fundamental, you are going to get derived unit. So we're going to look at derived unit. So derived unit is gotten by combining 2 or more fundamental units. So let us take one. We have, let's say, area. So for you to write the derived unit effectively, you must know the formula of the quantity. Once you know the formula of the quantity, the unit is very simple. So what is the formula for area? Area is length times breadth, or you say width, if you like. So remember, in our previous video, I said that length is also distance, breadth is distance, height is distance, meaning that they will have the same unit as distance. So the unit for area will be the unit for length, which is meter, times unit for breadth, which is also meter. If I multiply meter by meter, I'm going to have meter square. So meter square is the unit for area, or you can call it square meter. Number 2, I have volume. What is the formula for volume? The formula for volume is area times height. So the unit for area is what we got here, meter square, times unit for height, meter, because it is same thing as distance. So meter square times meter will give us meter cube. So meter cube is unit for volume, or call it cubic meter. The next, let's take speed. Speed is distance over time. That is unit for the formula for distance. For speed. So from the formula, I can get the unit. So what is the unit for distance? Meter. and the unit for time is second. So I'm going to have m over s. So in your law of indices, whenever you're dividing number indices, you subtract the power. So the power here is 1. So if this comes here, it becomes m s raised to power minus 1. So this is pronounced as meter per second. So meter per second is the SI unit, or the unit for speed. Next I have here is velocity. Velocity is displacement over time. So what is the unit for displacement? So displacement and distance have the same unit, just that this is a vector quantity and this is a scalar quantity. We're going to talk about that in our next video. So what is the unit for displacement? Displacement will be meter divided by what is time, second. So if I divide this by this, I'm going to have m raised to power minus 1 pronounced as meter per second. So velocity and speed have the same unit. Velocity and speed have the same unit. So the next I will take is, let's take acceleration. Acceleration is velocity over time, or you can say change in velocity over time. So if you divide velocity by time, you'll get acceleration. So what is the unit for velocity? We have gotten it as meter per second divided by time, second. Remember, this is raised to power 1. In your indices, when you divide, you subtract the power. So I'm going to have m. Since we have the same s here, I just take one of the s, then I'll subtract the power. I have minus 1 minus 1. Minus 1 minus 1 will give us minus 2. I have m s raised to power minus 2. So this is unit for acceleration, which is pronounced as meter per second square. The next I'm going to take is force. 5. Force. What is the formula for force? Mass times acceleration. Mass times acceleration. So what is the unit for mass? Unit for mass is kilogram times unit for acceleration is meter per second square. So if I combine this with this, or if I multiply this with this, I'm going to have kilogram meter per second square. Kilogram meter per second square is unit for force, or I call it Newton. Newton. So I can use this, or I can use this as unit for force, but this is majorly used. Next one, let's take pressure. Pressure is force over area. So what do I have here? The unit for force, I can use this, I can use this. Let me use both. So I'm going to use Newton divided by area is meter square. So if I divide this with this, I'm going to have Newton. If this comes or becomes meter square. So remember, you subtract when you are dividing. So that is why this is carry minus. So I'm having Newton per meter square. So Newton per meter square is the unit for pressure. Or I can say pressure is equal to force over area. So what do I have here? My force now, I'm going to use this instead of Newton. I'm having kilogram meter per second square divided by my area, which is a meter square. So this is the same thing as saying kilogram meter, let's say, times this divided by meter times meter. This will cancel this. So this will come up. Remember, it is 1. If it comes up, it becomes minus 1, which will give you kilogram per meter per second square. So this is also unit for pressure. Let's take work. The formula for work is force times distance. Feel free to pause the video at any time you're confused and go back to it. So force times distance is unit for work. So our unit for force, I can use Newton, then distance is meter. If I multiply this with this, I'm going to have Newton meter. So Newton meter is unit for work, or I can call it joule. Joule is also unit for work. Or I can decide to use the other unit for force, which is kilogram meter per second square. So I'm going to have work will now give me force times distance. So what is the unit for force? Unit for force will now be kilogram meter per second square times distance is also meter. So this will multiply this to give you kilogram meter square per second square. So kilogram meter square per second square is unit for work. So work is having three main units: kilogram meter square per second square, Newton meter, or joule. So these are unit for work. Then let's take another some other question example. Let's take power. Power will be work over time. So what is the unit for work? I have got unit for work as joule. I also got unit for work as Newton meter and this. So I can use any of it. So if I use the joule, I'll have joule over second, which will give us joule per second. So joule per second is unit for work. Another unit for work would be power rather, over time. So the unit for work here would be, I can use Newton meter divided by second. So if I divide Newton meter by second, I'm going to have Newton meter per second. This is also unit for power. Then we can also have another unit for power. Power will be equal to work over time. So our work, we got it as kilogram meter square per second square divided by second, which will give us kilogram meter square. This is 1, so if you take it up, becomes second minus 2 minus 1, which will give us kilogram meter square per second cube. So we have 4 units for power, which is this, that is 1 kilogram meter square per second cube. We also have joule per second. We also have Newton meter per second, and we have watt. So these are the units for power.